Hi, I'm Helen Thomas. Let's learn the working principle of electrolyte analyzers. Electrolyte analyzers are laboratory instruments that are used to measure the concentration of key electrolytes such as sodium, potassium, chloride, calcium, lithium, etc. that are present in the biological fluids like blood or urine or any other body fluids. These are critical for the diagnosis as well as the monitoring of the patients. The first methodology, the ISE technology. Here, the core principle is based on ion selective electrodes. Each electrode is selective for a specific ion. For example, sodium electrode is selective only for, or it will allow only the sodium ions to pass through. The electrode has a special membrane that allows only the target ion to interact or to pass through, generating a potential or voltage. The measurement principle. The sample, the blood or the serum, it comes into contact with the ISE membrane. The ion activity in the sample causes a change in the electrical potential across the membrane. The potential difference follows the Nernst equation, which states the voltage increases logarithmically with ionic concentration. The analyzer compares this potential to a reference electrodes and converts it into ion concentration. Types of measurement. In direct ISE, the sample directly contacts the electrode, while in indirect ISE, the sample is diluted first before the analysis. Internal calibration. Electrolyte analyzers use calibration solutions, which are standard solutions of non-ion concentrations, to ensure the accuracy. The analyzer automatically calibrates electrodes at set intervals. The output. The instrument processes the electrode signals, applies calibration, and displays the electrolyte concentration. In summary, electrolyte analyzers work on the principle of ion selective electrodes, which measure the electrical potential generated by specific ions in the samples and convert it into their concentration values using the Nernst equation. The traditional ISE analyzers are bulky electrodes with special ion selective membranes. So instead of the same, a newer methodology is introduced, that is ISE using the ICT or integrated chip technology. Here, instead of the large electrodes, miniaturized ISEs are integrated on a silicon chip. Each chip contains multiple ion selective membranes patterned side by side. This chip is inserted into the analyzer and tiny volumes of sample are enough for the measurement. The ICTs are embedded on a microchip to measure the electrolytes in small sample volumes. The principle is potentiometry. It measures the electrical potential that are generated by the specific ions, and the potential difference is directly proportional to the log of the ionic concentration, which is the Nernst equation. There are multiple ion selective membranes integrated on a single chip. The sample flows over microchannels contacting the electrodes. The advantage of the chip-based ISE is the miniaturization, that it requires only very small volume of the sample. The fast response or the results arrive in seconds due to the microfluidic design. Integration, that is the multiple electrolytes can be measured on the same chip simultaneously. So it's rapid and simultaneous multi-ion measurement is possible. The portability, it enables the handheld or bedside analyzers. Disposable chips come in these analyzers which reduces the contamination and cross-sample carryover. It is automation friendly. It could be used in compact analyzers with self-calibration, and also the results that are produced are of high accuracy and reproducibility. Another technique called flame photometry was employed in electrolyte estimation. It is otherwise called flame atomic emission spectroscopy. Still, it is in use today in some industries such as soil, fertilizer, and beverages industry. But in the clinical labs, it is greatly replaced by the ISC methods and automated electrolyte analyzers due to the ease of use and the speed. The principle of flame photometry is emission spectroscopy. In this, a solution or the sample that contains the metallic ions is sprayed into the flame. First, the sample is expected to go through a nebulizer and it is then sprayed into the flame. The solvent will get evaporated and the fine solid salt will remain. The heat of the flame converts this salt into free atoms. The atoms will get excited to a higher energy level due to the thermal energy of the flame. When they return to the ground state, they emit light of a characteristic wavelength. The emitted light intensity is directly proportional to the concentration of the element in the sample. Thus, the flame photometry works on the principle of exciting atoms in a flame and measuring their characteristic light emission, which is directly proportional to the ion concentration. Thank you for watching.